In this tutorial, we're going to learn how to create a validator for a credit card number using the LON algorithm, which is used to help validate credit card numbers. We are given a positive integer of up to 16 digits. Return true if it's a valid credit card number or false otherwise. Here is the algorithm. Double every other digit, scanning from right to left, starting from the second digit from the right. So this one. We have here a couple of examples so we understand how we need to do this. Another way to think about it is if there are an even number of digits, double every other digit starting from the first. So even number, we start with the first one and then the third one. If there is an odd number, like in this case, we start with the second and the fourth. Well, start with the second and go the fourth and so on. Alright, if a resulting number is greater than 9, replace it with the sum of its own digits, which is the same as subtracting 9 from it. Yeah, so basically if we have a number which is greater than 10, then we need to subtract 9. Alright. Sum all of the final digits, 8, 9, 1, which will be 18. Finally, take the sum and divide it by 10. If the remainder equals 0, the original credit card number is valid. So here we have 18 modulus 10, which is 8, not equal to 0, so this is not a valid credit card number. Alright, so let's implement this algorithm. First up, we're going to need to split this number into digits. So let's do that. We're going to say digits and we're going to use n to a string. We're going to convert it to string and then we're going to split so that we now have, if we console.log this, we have an array of digits, but the digits will be, well, in strings. So we could add a map and we can convert them to number, passing the number constructor there. So let's see how this looks now. We get all the numbers inside of an array. Good. Now we basically need to see the length of this array, if it's an even number or an odd number. If it's an even number, we want to double the first, the third, and so on. If it's an odd number, we want to double the second and the fourth and so on. So let's do the check. If digits.length modulus 2 is equal to 0, so this means we have if it's an even number, then here we want to double the first one and third one and so on. Well, let's put this in a let so we can change this. Digits will be digits.map. We're recreating a new array and assigning back to digits. This is not the best approach, but for now, just to lay out the foundation, it should work. And then at the end, we could improve it. So we want to map over the digit. So we get a digit and we get the index, right? So now we need to check if the index is not even. Index modulus 2 equals to 1. Then we want to double it. So digit times 2. Otherwise, we return the digit. And else, we want to do pretty much the same thing, but we need to check here if it equals to 0. Alright, let's see what we have in the digits now. We should hopefully see the right doubling process. Okay, so we have 2 to 6, and we're getting 1, 2, 3. So it doubles the first and the third. Let's see, that's what we want. Not really, so my bad. I forgot that the indexes start with 0. So we need to change this. First index is 0, so the remainder division with 2 is 0. So then that's what we need to double. Alright, let's test it now. And yeah, we get the correct version now. So it doubles the second one. Let's see. Yeah, the second one. Perfect. Now the only issue is that if we double here and we get a bigger number than 10, we need to subtract. we could do it here, or we could do another map and do it separately. So let's do it here. Fix the double digits. So digits will be digits.map. We're going to go over the digits again. We don't need the index, so as an arrow function, we can avoid the parentheses now. So if the digit is greater than 10, then we want to return digit minus 9. Otherwise, we want to return, oops, this should be the question mark. Otherwise, we want to return the digit. Awesome. Now we don't really have a test for a number greater than 5, well, than 4, so it will see the double. So let's add it here. 5, 6, 7, 8, 9. All right, let's test it. And we can see here that we double the 6, we got 12, and then we subtract 9. Is that what they want? Let's see. If a resulting number is greater than 9, replace it with the sum of its own digits. So yeah, we have 6 times 2 is 12. And if we add the digits, 1 plus 2 is 3. And that's what we have here in the output. Perfect. Let's see for 8. We have 16. 1 plus 6 is 7. Pretty good. And the last thing will be to sum all the digits. And for this, well, we can actually return the digits that, let's see, sum the digits. And we can return the digits that reduce. Here we have an accumulator, and we have the digit, and we're going to return accumulator plus equals digit and start with 0. So now we should get the sum. Well, actually, we don't need to return this because we have one more step. We need to do the modulus. All right, so const sum equals, and we return sum for now. Let's see what sum we have. Okay, so we have 8, 1, 10, 10, 40, 30, 10, 80, 10. All right, and this should be true. As you can see here, this should be false. All right, so this doesn't look right for now. We need to check why is that. But let's do the last step. So we need to see if the modulus 10 will be 0. So modulus 10 should be 0. This is what we want to return. And yeah, we have one failing test. Let's see what are the digits and go over step by step. So for the failing one, we have 8675309. All right. Then let's see what we have here after the digits. So after we double the digits, well, actually, yeah, let's see there and here also. Here we double it and here we fix the double. Let's see what we have here. So we can debug it step by step. All right, so we get, this is an 1, 2, 3, 6, 7. So it's an odd number. And for odd numbers, we need to double the second and the fourth and so on. So let's see. The second, the fourth, and so on. Oh, okay. I see where the issue is. We checked here if the digit is greater than 10. But well, actually 10 is also a 2-digit number. So we want to check if it's greater than 9. All right, let's test it now. And look at that, it passed. Pretty good. Now let's see how we could improve on this. As of now, we kind of just reassign to this digits array, which is not the best approach. One thing will be to convert this to a function. So basically this step. So let's create a function, check if double, or well, let's do it, fix double. And it gets a number. And here we pretty much did this. So we return, and here, well, we have the number, not the digit actually. So number. All right. And here we can remove this now and use this fixed double to pass in the digit times 2. Alright, one is down, a couple of more left to go. Maybe we can use this sum here. So let's create a sum just for now. And instead of reassigning the digits, we're going to create a sum. And we're going to do the reduce here at the end. Alright, let's see if this still works. Alright, it does. Now the last thing we'd like to fix is that we pretty much repeat ourselves here. How could we improve this? Well, you can see here that the only difference between these two lines is this check. And well, basically this check is 0 and so it's the if here. So we could kind of get this and place it here, right? And well, let's check. So we can remove this entirely, put this as a sum, convert this to const, and this also. And well, maybe let's put this in the second row, just so we can see it better. Although it's, yeah, pretty complex-ish now. All right, let's see if this still works. And it does. Pretty nice. And maybe as last step, let's add some comments here. So convert number to an array of digits, like that. Then here, we basically had some steps. Double every other digit from right to left. Well, we basically do the second part, but it should be pretty obvious if they look at the description. Okay, and here add the digits. All right, and yeah, well, this will be the check, so that's pretty obvious. And this pretty much says what it does. Fix double. All right, let's attempt this again, see if it all works. Let's submit, and also let's check how others did it, just so we can learn even more. All right, so here we have a sum. Oh, I see what he's doing. So it's using modulus 10 to get the last digit, and then he wipes out the digit. All right. Yeah, so it's starting from the right, which is pretty good because now he doesn't need to do the check if it's even or odd. All right, pretty good. And then here he takes the second one from the right, multiplies by 2, and if b is greater than 9, he subtracts 9, and he adds it to the sum. Yeah, this is pretty clever, and also I'd say it's a bit easier once you get how this works. All right, let's see this one. To number, split, map, reverse. All right, I see what he did here. And that's also a good idea. We haven't thought about using reverse, which could have saved us from doing that check if it's even or odd. And then he uses reduce, sum, digit, or index. Now I don't really understand this. I don't know bitwise operations and stuff like that, but it feels pretty good. I think this is like doubling it, probably. And yeah, it does the modulus and equals 0. Pretty nice. All right, let me know if you like this kind of tutorials of me going over different coding challenges and not having like a preparation in the beginning. So we're kind of doing it on the fly. Let me know if you understood something or if you didn't. And well, if you like this kind of tutorial, give it a like, subscribe for more tutorials like this, and I'll see you in the next one. Bye.